Hi everybody, so this is the second screencast dealing with percent composition problems. All right, again at the top, as you can see, we have the formula for the percent composition of an element, which is the mass of the element divided by the mass of the molecule times 100%. I also have an example of a table, all right, where I have magnesium fluoride as my example. And for the table, I set it up with two columns, mass and percentage, and I have the parts, which are magnesium and fluorine, and then the whole, which is magnesium fluoride. Don't forget, right, you can always fill in the percentage of the compound. It will always be 100%. All right, so we're going to go down to problem number 2, and we're going to try this one. This one's a little bit different. It says a sample of a compound with a mass of 0.432 grams is analyzed. The sample is found to be made up of oxygen and fluorine only. Given that the sample contains 0.128 grams of oxygen, calculate the percentage of each element within the compound. All right, so we've been given two numbers. We've got grams of compound and we have grams of oxygen. And we're asked to find the percentage of each element, not just one, but both. All right, so I'm going to start again by putting together a table. It just works best for me. Again, not required. All right, so I start with the C for compound. I don't know the formula, so I'm just going to put a C. And then my two parts are oxygen and fluorine. All right, and within this table, I'm going to have my two columns, my mass and my percentage. And then I'm going to fill in what I've been given or what I already know. All right, well, I have 0.432 grams for the amount of the compound and 0.128 grams for the amount of oxygen, and I know that the percentage for the compound will always be 100%. So I have these numbers already. All right, so if I look at this table, I can figure out the amount of oxygen, the percentage of oxygen, because I know the amount of the whole, I know the amount of the part of oxygen, so I can use those values in my formula to find that percentage of oxygen. So that's going to be equal to the part, which in this case is 0.128 grams of oxygen, divided by the whole, which is 0.432 grams of my compound, and then multiplied by 100%. So if I take my calculator and I do that multiplication and then division, or vice versa rather, I get a percentage of 29.63% oxygen within this compound. All right, so that fills in this box for us. All right, now the problem here is that we need to also figure out the percentage of fluorine, but I don't know that mass value, so I can't use my percent formula until I have it. So I could technically use the conservation of mass to take that whole mass and the part and then use it to find that mass of fluorine. But another option is to take my percentage column and use those two numbers to directly find that percentage. All right, the percentage of a compound is always going to be equal to the sum of the percentage values for the parts. So in this case, the percent of the compound will be equal to the percent of oxygen plus the percent of fluorine. And for percent composition, that compound is always 100%. So if I take the 100% and set that equal to the percentage of oxygen at 0.2963, and my unknown, which is the percent of fluorine, I can use algebra to solve for that percentage of fluorine. So I'll subtract 29.63 from 100, and I find that the percentage of fluorine should be equal to 70.37%. All right, so there's a way to directly find that percentage when you have the two percentage values for the rest of the compound. Okay?